The gaping chasm separating our blue planet and NASA's Voyager 1 probe is now about 15 billion miles away. Only one crewless spacecraft in history, called Voyager 2, has ever made it thus far into space. Nevertheless, the probes launched in the 1970s continue to frequently provide crucial new information to planetary experts. How has the Voyager mission that began more than 40 years ago been going strong? What did we learn from the trip? And what can we tell you about the strange plasma waves that Voyager 2 saw deep in space? With you, we'll examine one of space travel's biggest success stories in more detail today. Would you want to regularly learn about space agencies' fascinating findings and special missions? Then keep in mind to click the bell icon and subscribe to Space School to stay informed. By sending us a thumbs up, you encourage us and demonstrate that you're interested in the information we offer. Let's look at how the Voyager space probe program started. It's well known that the Voyager probes, developed by NASA, were sent into the vast reaches of space for the first time in 1977. 45 years after their launch, the two crewless spacecrafts are still in orbit and are now establishing close contact with the solar system's outermost regions. This is the first time any human-made object has ever made such contact. However, suppose one considers the primary objectives of the large-scale research mission. In that case, nobody in the 1970s could have foreseen that the Voyager program would become the longest-running space mission in the history of space exploration. So when the two spacecrafts blasted out from the surface of our home planet, our understanding of the regions beyond our solar system's known planets was still somewhat limited. Therefore, the mission objectives included investigating the surroundings of Jupiter and Saturn, doing the geological investigation of the moons, examining distinct magnetic fields, and obtaining information about the composition of particles and plasma and where they're distributed. And to begin, everything proceeded according to plan. After reaching Jupiter, Saturn, and their respective satellites, the Voyager 1 spacecraft moved to make precise measurements and sent numerous photographs back to our blue homeworld. The information gathered during that period brought our understanding of the mighty planet Jupiter and its famous ringed system to a new level. In addition to discovering multiple previously undiscovered moons of Saturn, it also demonstrated that the planet's ring system is a complicated structure of thousands of distinct orbits rather than a uniform body. The expedition also enlightened scientists that Jupiter, the largest planet in our solar system, has its own ring system. However, in addition to the many discoveries, the Voyager probe successfully captured some magnificent images. Even if they had no scientific usefulness worth noting, they retain total legendary status. Examples include the so-called family picture of our planetary system. 6 of the planets that make up our solar system are shown in color in the picture mosaic. In addition, the photograph that later became famous as the pale blue dot was all over the news. The shot was obtained from the most considerable distance possible, around 4 billion miles away. Additional advancements were made throughout the mission. After visiting Jupiter and Saturn, Voyager 1 proceeded on its journey into interstellar space, whereas Voyager 2's exploration route included numerous more stops. The probe had been in orbit for 8 years by the time it reached Uranus in 1985, which was more than twice as long as its original lifespan had been estimated. Remarkable insights were also found during this period. In all, 10 more Uranian satellites were found. However, on August 26, 1989, 4 years later, Voyager 2 flew through Neptune at around 3,000 miles. At the same time, almost 9,000 pictures of the icy, glittering planet were sent back to Earth. Voyager 2 reportedly made the first discovery of the ringed structure around the planet. On the other hand, the magnetic field's measurements showed that this field was less strong than the scientists had predicted before the expedition. One of Neptune's newly found satellites, Triton, quickly became the center of scientific attention, even as 9 other moons of the planet were added to astronomical observations. Triton's diameter was formerly thought to be as vast as 3,000 miles. However, Voyager 2 demonstrated that it was closer to 1,500 miles in size. Additionally, the satellite's surface had a rippling appearance rather than craters. Eventually, the celestial body's brownish-white color was determined to result from volcanic processes. In this volcanic process, massive amounts of liquid nitrogen are ejected from geysers into the atmosphere. As a result, it partially freezes and eventually descends as white nitrogen snow on the planet's surface. Now, the start of a cosmic voyage. Once Voyager 2 made it beyond Neptune, it was time for it to join its sister expedition on an exploratory mission to the outer regions of the solar system and beyond. Overall, this interplanetary mission's aim is to learn as much about the solar system's edges and the deep encompassing space as possible. Meanwhile, the space area outside the galaxy's stars is called interstellar space. Experts refer to interstellar space's matter, radiation, and magnetic fields as interstellar medium. However, dust and gases in the ionized atomic and molecular state constitute its most crucial component. Voyager 1 came close to the heliosphere in 2002 and 2003. The heliosphere encompasses a vast area surrounding the Sun, and its magnetic fields and solar wind are active here in the heliosphere's far outer region. In addition, the solar wind slows down when it enters the heliosphere and combines with interstellar materials. Researchers were aware that Voyager 1 had arrived at the heliosphere's border zone in December 2004. The data gathered by the probe's magnetometer suggests, in addition, that a powerful magnetic field existed outside of the solar system. The rapid slowdown of the solar wind and unanticipated changes in the magnetic field led to this conclusion. In the process of coming to this insight, it might be possible to find a solution to the primary issue of why the nearby interstellar blanket does not disperse. The reason is that it has a powerful magnetic field responsible for keeping it together. In 2010, there were growing indications that the Voyager 1 spacecraft was approaching the heliopause from a closer distance. Finally, in 2012, the moment had arrived. The probe had relayed that the number of anomalous cosmic rays had significantly decreased, while the number of galactic cosmic rays had swiftly increased, a startling sign that Voyager 1 had exited the heliosphere and had crossed through the heliopause. The Voyager 1 spacecraft is about 15 billion miles from Earth as of February 27, 2022. Consequently, on November 5, 2018, Voyager 2 reached interstellar space. The current distance between the two is around 12 billion miles. Communication systems between the two spacecrafts are expected to be lost sometime in 2036. Despite this fact, the spacecraft has not yet reached its final destination on its trip. In about 40,000 years, Voyager 1 will go by the star Gliese 445. This is assuming that nothing unexpected happens between now and then. In an even far-off future, in the next 250 million years, the probe will have traveled a distance comparable to traveling around the Milky Way's core. Strange fluctuations may be seen in the plasma. Being the first of 2 space probes to leave the solar system, the scientific community was disappointed by Voyager 1's entry into interstellar space. Its plasma measurement device had been damaged. The good news is that the matching payload on the counterpart Voyager 2 was still operational. Nevertheless, a closer look at the data revealed a new cosmic enigma to the researchers. Studies show there may be another layer between the Sun's heliosphere and interstellar space. This suggests that the barrier between the solar system and interstellar space is not smooth, but has a stepped structure, as indicated by the recently found boundary layers. However, the scientists also tracked a considerably thicker layer beyond this previously identified zone, via which interstellar plasma flows into the heliosphere. When these erratic motions occur, the plasma density in a region that spans billions of kilometers suddenly rises by 20-fold. Each of these factors points to the presence of a plasma-compressing entity in the corresponding region. The issue is that scientists are at a loss to explain it. To learn more about the origins of this remarkable finding and the makeup of the solar system's edges, we need further study expeditions. For instance, scientists are preparing to dispatch additional space missions to the solar system's most distant regions to investigate these regions in an even more insightful manner. Now that we've covered everything, we want to hear your thoughts on Space School. What are your thoughts on the fascinating Voyager program, which has captivated professionals and non-professionals for the past 4 decades? And what are your thoughts on the puzzling finding discovered by Voyager 2 as it traveled across interstellar space? In the comments section below, we would appreciate if you could share your opinions, ideas, and remarks on today's video. Fancy seeing some more exciting clips on fascinating space-related subjects? Then keep in mind to click the bell icon and subscribe to Space School to stay informed. Check out our other uploads by clicking on the thumbnail on the end of the screen you're seeing. To anyone who's watching this, I appreciate your time and consideration. Please be safe till we meet again.